Thinking back to earlier in the semester, there's a few things that we know about inverse functions. The first thing that we know about inverse functions is that we can find a function's inverse by swapping the variables. Switch or swap the locations of x and y, and then solving for y, isolating the output variable. We also know something about the domain and range of inverse functions, and that they also swap. So if I know the domain of a function and the range of a function, I also know its inverse's domain and range. The domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So in each of these, I'm starting out with an original function. My goal is to find the equation for the inverse function, as well as the domain and the range for the inverse function. So if I look at number 13 here, the first thing that I'm going to do is analyze the original function's domain and range. I know that for logarithmic functions, there's a limitation on the argument. X minus 3 has to be greater than 0, which means my domain here is x has to be greater than 3. The range of logarithmic functions is all real numbers. Finding the inverse function now is going to require me to swap the location of my variables and then solve for y. So I'm going to first divide both sides by 2. I get x over 2 is equal to the log base 4 of y minus 3. I'm going to move that base of 4 over to the other side so that I can get the argument by itself. So this is going to be 4 raised to the power of x over 2 is equal to y minus 3. My last step is going to be to add 3 to both sides, giving me my inverse function y is equal to 4 raised to the power of x over 2 plus 3. This is, again, my inverse function. Now, I already know the domain and range of that inverse function because I know the domain and range of the original function. The domain of this inverse is going to match the range of the original, so it's going to be all real numbers. The range of the inverse function is going to match the domain of the original, so that's going to be from 3 to infinity. So that's the second part of my answer. I'm going to approach number 14 in the same way. To me, it's easier to find the domain of the logarithmic function, so I'm going to save that for once I find the inverse. So I'm going to start this one by swapping x and y so that I can solve for the inverse function. Reverse PEMDAS order, I need to subtract 5 from both sides. I get x minus 5 is equal to negative 3 raised to the power of y minus 2. That negative is outside of the base. So I'm going to divide both sides by negative 1. You could also think of it as multiplying both sides by negative 1. So I get negative x plus 5 is equal to 3 to the power of y minus 2. Now is where it's going to become a logarithmic function. I'm going to take that base of 3, move it over to the other side. I get log base 3 of negative x plus 5 is equal to y minus 2. Last step is going to be to add 2 to both sides. So I get log base 3 of negative x plus 5 plus 2 is equal to y. This is my inverse function. Like I said, it is easier for me to find the domain and range of this logarithmic function. The domain, again, is going to come from that argument, has to be greater than 0, so I get negative x has to be greater than negative 5. When I divide by negative 1, everything becomes the opposite, so I get x has to be less than 5, which means my domain for my inverse function is going to be negative infinity to positive 5. The range of any logarithmic function is all real numbers.